All right, a couple days ago, we were talking about simplifying radicals. And today we're going to talk about applying simplifying radicals and using radicals to equations. So we're going to be solving equations by taking the square roots. All of these equations have in common is they all have perfect squares. None of them have the bx term in terms of how they're presented. And we can solve these some other ways. Now, these two problems here, we have set A and set B. They're completely different. All of the problems in set A are some variation of a difference of squares. All of the equations in set B are perfect square trinomials, where you have a bx term. So one of the key factors of this is you don't want to have a bx term, but we'll come and visit that a little bit later. So we're going to talk about, here's one way that this equation, p squared equals 16, can be solved. So typically, previously, we would have moved the 16 to the side with px. So this would become p squared minus 16 equals 0. And then in that situation, we would factor it. So we know that the p squared would go there, then minus 16 would go there. We know that these two terms here, our little peanut, would have to be equal to 0 because there's no bx term. And so that we know we're going to have a plus and a minus, and of course the factors of 16 that are going to add up to 0 are going to be plus and minus 4. So that's going to give me p plus 4 and p minus 4 for our factors. So our factors here are going to be p plus 4, p minus 4, and that's going to be equal to 0. Then we know that when we set p plus 4 equal to 0, or 0 minus 4 equals to 0, x, not x. X minus 4 is equal to 0. That's going to give me p is equal to plus or minus 4. Okay?